Section 22.2 Groundwater. So water rains down as precipitation, and then it'll soak into holes in the ground, and that water will collect underneath the ground inside of porous regions inside the soil. We call this water groundwater. Most of Earth's fresh water resides as groundwater, about 98.5% of it. The remaining 1.5% makes up everything else that we see, all of the lakes, ponds, rivers, streams, all of the other waters underneath the ground. The type of material the ground's made out of determines how much moisture it can absorb. For example, things like sand will absorb moisture more easily. Things that are very rocky or gravelly will not. And water that's not absorbed is called runoff, and runoff will flow essentially downhill into a stream or a river or some other body of water nearby. If we look beneath the ground, we have two regions of space, regions where there is groundwater present and regions where there is what's called soil moisture. Whenever you have a region where all of the space is filled with water, we call that region a saturated zone. This is where the groundwater resides. Above the saturated zone is a region known as the unsaturated zone, and this is where you'll find moist soil, but not every bit of space is filled with water. So the soil moisture resides in the unsaturated zone. And the unsaturated zone also contains air where the spaces are where there's no water. It's not completely filled with water. So you can pump water to the surface through something like a well. But if you try to do this in the unsaturated zone, what happens is the air will cause a loss of pressure, and it just makes it impossible to pull water up. And so this is the same effect that you get when you accidentally crack a hole in a drinking straw and you try to drink out of it. You get some drink, but a lot of air. So the amount of water that the ground can hold depends on what's called the porosity of the soil or the rock that makes up the ground. Porosity is just a measure of the open pore space, the open space inside of that soil or rock. It depends on the size and the shape of the soil and whether or not that soil is tightly packed down. So sand has very small grains, and when it piles on top itself, there's not going to be a lot of space in between each of those grains of sand, which means that it would be less porous than, say, a pile of gravel, where when it piled on top of itself, there would be a lot of space between each of those rocks. Now, porosity tells you how much water a sample can hold, but it doesn't tell you anything about how water moves through the sample. What we call the hydraulic conductivity or permeability of a material determines how easily it can transmit water. A higher permeability means that water can move more easily through that particular sample. A lower permeability would mean it moves less easily. So if you dig straight down into the ground, you'll first reach the unsaturated zone, and if you continue digging, eventually you'll reach a point where every time you keep digging, the hole will just fill with water. This is the upper boundary of the saturated zone, where the groundwater is, and that upper boundary is referred to as the water table. The water table is not fixed in any region, and it can vary based on precipitation and the climate. In regions where you have droughts, this is when you see the water table significantly lowered, and people who rely on things like wells for water may have trouble getting water because their well may no longer be beneath the level of the water table. Now, any underground region where water can flow is called an aquifer. And aquifers underlie about half the land surface under the U.S., and they contain a great deal of water. A lot of regions get their water from aquifers. Whenever the surface has a high permeability and water can move very easily through it, it can move through the ground and get into the aquifer. If rainwater can reach it, then that aquifer is considered unconfined. If the permeability is low and rainwater can't get to it, then you have a confined aquifer. In terms of the way that water moves underneath the ground, gravity is the major factor that drives groundwater movement. Water is always going to travel downhill. And so the slope of the water table is what's known as the hydraulic gradient. And it's directly related to the flow rate of groundwater, how quickly groundwater flows. And so the flow rate of any particular region of the ground is proportional to the permeability, so how easily water can move through that material, the area, how much space you're actually talking about, and the hydraulic gradient, how steep is the water table underneath the ground. A steeper water table implies that the water would move more quickly.